In the far reaches of our solar system, beyond the orbit of Neptune, lies a mysterious region filled with icy bodies known as Trans-Neptunian Objects, often abbreviated as TNOs. This is the part of the cosmos that belongs to the outer solar system, a place shrouded in cold darkness and still holding many secrets. For a long time, astronomers had little idea about the diversity that might exist out there. But discoveries over the past few decades have transformed our understanding of this distant frontier. Pluto, revealed to the world in 1930, was the first trans-Neptunian object to be discovered. For many years after its detection, Pluto was considered the only significant body orbiting beyond Neptune. It was classified as the 9th planet of the solar system, and few astronomers thought to search for more. The scientific consensus was that Pluto stood alone, and so systematic hunts for similar objects simply did not take place. For decades, Pluto was believed to be a singular wanderer in the frozen darkness. That belief began to change in 1992 with the discovery of a second TNO, later named Albion. This moment marked the beginning of a new era in planetary science. Suddenly, astronomers realized Pluto was not alone. Careful surveys of the sky were launched, photographing wide regions near the celestial equator and examining them for faint, slow-moving points of light. These painstaking efforts revealed an astonishing population of objects. Hundreds of TNOs were eventually discovered, their sizes ranging anywhere from 50 kilometers to an impressive 2,500 kilometers across. Among them was Eris, found in 2005, one of the most massive TNOs known. Its discovery ignited a heated debate in the scientific community about what truly qualifies as a planet. Should Pluto keep its status, or was it time to rethink the definition?
Ultimately,
both Pluto and Eris were reclassified as dwarf planets by the International Astronomical Union in 2006, a decision that reshaped how we view our solar system. Of all TNOs, Pluto remains the most famous. It resides at an average distance of 39 astronomical units from the Sun, roughly 6 billion kilometers away. At that distance, sunlight is so weak that the world exists in a kind of perpetual twilight. The temperatures are unimaginably cold, and towering mountains of water, ice rise from its frozen plains. Thanks to the New Horizons mission, which flew past Pluto in 2015, we know it to be a world of stunning variety, with glaciers of nitrogen ice, blue hazes in the sky, and even possible subsurface oceans. But beyond Pluto, discoveries have only grown more fascinating. In December 2018, astronomers announced the detection of an object even farther away. Catalogued as 2018 VG18 and nicknamed Pharaoh, this distant body, about 120 astronomical units from the Sun, became the most remote object observed in the solar system at that time. Its orbital period is staggering. It's taking an estimated 738 years to make a single journey around the Sun. This discovery reinforced the fact that our solar system extends much farther into the void than most of us ever imagined. Today, astronomers have identified nearly 3,000 TNOs, and it is believed that many thousands more remain undiscovered, lurking in the darkness. Let us now explore some of the most intriguing members of this distant family of worlds. One of the most remarkable is Haumea, discovered in 2003. Haumea resides in the Kuiper Belt, the broad ring of icy bodies beyond Neptune. Comparable in size to Pluto, Haumea is composed of rock coated by a thin layer of ice. What makes Haumea especially fascinating is its incredible speed of rotation. A single day there lasts only about 4 Earth hours, making it one of the fastest spinning large objects in the solar system. This rapid spin has given Haumea an elongated football-like shape. With a radius of about 620 kilometers, it orbits the Sun at an average distance of 43 astronomical units, taking 285 years to complete one full orbit. Astronomers believe that Haumea's strange shape and rapid spin may have been caused by a giant impact long ago, which may also have formed its 2 moons Hayaka and Namaka. It's even more fascinating in 2017. This was an extraordinary revelation, proving that ring systems are not unique to the giant planets. Another noteworthy TNO is Makemake, also located in the Kuiper Belt. Slightly smaller than Pluto, it is the second brightest object in that region, after Pluto itself. At a distance of about 45 astronomical units from the Sun, Makemake requires roughly 305 years to complete a single orbit. With a diameter of about 1,400 kilometers, it rotates once every 20 hours. In 2006, astronomers detected a small moon orbiting Makemake. It's provisionally named MK2. This moon is extremely faint, about 1,300 times dimmer than Makemake, and around 160 kilometers in diameter. The discovery of MK2 allowed scientists to begin estimating the mass of Makemake more accurately, adding to our understanding of these distant objects. Eris, discovered in 2005, is one of the largest dwarf planets in the solar system, nearly the same size as Pluto, but orbiting much farther away. With a diameter of about 2,300 kilometers, Eris orbits the Sun at an average distance of 68 astronomical units. 1 year on Eris lasts 557 Earth years. It possesses a single known moon, Haumea, which circles the dwarf planet every 16 days. Eris is so cold that scientists believe its atmosphere freezes and collapses onto the surface as a layer of frost. When it is at its farthest point from the Sun, reforming only when it comes closer. This cycle of atmospheric collapse and renewal makes Eris one of the most fascinating bodies in the outer solar system. Gong is another remarkable TNO, discovered in the scattered disk region beyond the Kuiper Belt, with a diameter of about 1,230 kilometers. Gong is similar in size to Charon, Pluto's largest moon, making it the fifth largest known TNO. Gong's orbit is highly elongated, ranging between 33 and 100 astronomical units from the Sun, and it takes 554 years to complete one orbit. Its rotation is unusually slow, between 22 and 44 hours. It's likely due to tidal interactions with its moon Shangblue, discovered in 2010. Shangblue, about 100 kilometers wide, orbits Gong at a distance of around 15,000 kilometers, taking about 25 days to complete each circuit. Sedna, discovered in 2003, is perhaps the most mysterious of all TNOs. It has an extremely elongated orbit that takes it far beyond the Kuiper Belt. At its most distant point, or aphelion, Sedna lies nearly 937 astronomical units from the Sun. To put that in perspective, that is about 31 times farther from the Sun than Neptune is. Sedna's orbital period is astonishing, about 11,400 years. With a diameter of roughly 1,000 kilometers, it is often considered a dwarf planet, though its exact mass is not yet well understood due to its distance. Sedna's reddish surface is composed of a mixture of water, ice, methane, nitrogen, and complex organic compounds called tholins. What makes Sedna particularly fascinating is its high perihelion distance of 84 astronomical units. Unlike most TNOs, Sedna's orbit does not appear to have been shaped by Neptune's gravity. This suggests that Sedna might have a different origin. Some astronomers propose that Sedna is the first known object belonging to the inner Oort cloud, a vast, distant reservoir of icy bodies. Others speculate that Sedna's orbit could have been shaped by the gravitational influence of a passing star in the early history of the solar system, or even that Sedna was captured from another planetary system entirely. There is tantalizing evidence that, in the distant past, a star may have passed through the outer solar system, disturbing objects and leaving a trail in its wake. The exploration of these Trans-Neptunian objects reminds us how little we still know about the boundaries of our own solar system. With each discovery, Pluto, Eris, Haumea, Makemake, Gong, Sedna, and many others, we are forced to expand our understanding of what planetary systems can look like and how they evolve. Nearly 3,000 TNOs have already been cataloged, but countless more likely remain hidden, waiting to be discovered. Each of them carries secrets about the formation of our solar system, possibly about the origins of planets themselves. The story of the outer solar system is still being written. New telescopes, new surveys, and future missions may one day visit these distant icy worlds, revealing their landscapes, atmospheres, and histories in detail. Until then, they remain glittering mysteries, silent sentinels orbiting in the cold darkness beyond Neptune. And as we continue to push the boundaries of astronomy, one thing becomes clear: the solar system is far larger and more complex than we ever imagined. Every discovery brings us closer to understanding the grand design of the universe.